The horned dinosaurs are among the most iconic of all extinct animals, known for their impressive frills and facial horns. Dominating the late Cretaceous period, they were very diversified and are almost all found in North America. Ugueto, a primitive form, lived during the late Cretaceous in the western Tethyan archipelago, in what is now Europe. It was originally described as a ceratopsian most closely related to forms in East Asia, from where its ancestors may have migrated by island hopping. Later research however has questioned this assignment, and treats Ugueto as an ornithischian of unresolved affinity. Although the fossils are fragmentary, the paper describing it estimated a body length of 1 meter. The fossils were discovered in the Cebanha Formation, which is interpreted as a floodplain and channel deposit formed by variegated clay, silt with interbedded gray and brown sand, and sandstone beds. Ceratopsids was discovered in New Mexico, and dates to the late Cretaceous. Estimated to have been about 3.5 meters long, it was one of the earliest ceratopsians with well-developed horns over its eyes. It had a transitional mix of features between basal ceratopsians and the later larger forms, having brow horns and a long narrow snout, but a frill lacking decorative scalloped edges, suggesting that the horned ceratopsids evolved from more primitive ancestors already within North America rather than migrating in later from Asia. Bones from several different individuals have been found, showing that their teeth became more firmly rooted with age, going from single-rooted in juveniles to double-rooted in adults. The brow horns also appear to have grown continuously throughout Ceratopsids' life, with those of older specimens being much larger. Specimens of Ceratopsids are known from the Moreno Hill Formation, which documents a time of tectonic upheaval, volcanic activities, humid paleoclimate, and North American coastal margin shifts. Tyrannoceratops lived slightly later than Ceratopsids, approximately 90 million years ago during the late Cretaceous period. Measuring around 2 meters in length, it was a small transitional species closely related to the true ceratopsids. However, there is ongoing debate about whether it should be classified as a true member of that group. Fossils of Tyrannoceratops were discovered in Uzbekistan, making it the earliest ceratopsid-like dinosaur found in Asia rather than North America. This suggests that ceratopsians were still migrating between the two continents. Only fragmentary remains have been uncovered, so while it's known to have had large brow horns, the presence of a nose horn and the exact shape of its frill remain uncertain. Therefore, much of its reconstructed appearance is speculative. Centrosaurs are primarily known from the northern regions of western North America. However, some species ventured further south, with fossils found as far as Mexico. These dinosaurs often featured prominent spikes on their frills, and many also developed large nose horns or nasal bosses. Diabloceratops, meaning devil-horned face, was one of the earliest members of this group, living around 80 million years ago. Found in Utah, it likely measured about 5.5 meters in length. This species had a small nose horn, relatively short brow horns, and a pair of long, devil-like, spikes at the top of its frill, which inspired its name. It had a shorter, deeper skull than its later relatives and retained some primitive traits from its ancestors. It was also the first centrosaur discovered south of Montana, suggesting that the group may have originated in the southern part of the continent before its descendants dispersed northward. Compared to their sister group, Chasmosaurinae, Centrosaurines are relatively small. Ceratopsian dinosaurs from the Judith River Formation have been studied for over a century, but their diversity remains unclear due to fragmented specimens. The newly described Ceratospoidea is based on a nearly complete skeleton from this formation. It is distinguished by unique features like anteriorly oriented horn cores and a distinctive nasal structure. Cladistic analysis shows it is an early diverging Centrosaurine, closely related to Ceratospoidea. Its ontogeny suggests early co-ossification of cranial elements, similar to Triceratops. The well-preserved, disarticulated skeleton will be valuable for future ceratopsian studies. Ceratopsids would have measured around 4.8 meters long, and had very long horns, curving out to the sides and then twisting forwards into a shape that convergently resembles those of modern cattle. It appears to have been part of a unique side branch of the early centrosaurs known as the Ceratopsians, which had long brow horns, small nose horns and only modestly decorated frills compared to their other relatives. This group also includes representatives from further north such as Avaceratops and several other still unnamed specimens. Its snout was short and deep, with an unusually huge nasal cavity and shows evidence of pneumatic air sacs. Skin impressions were also found around its left shoulder, showing a pattern of 1 cm hexagonal scales surrounded by smaller triangular scales. Xenoceratops was one of the earliest centrosaurs identified in Canada, with fossils found in Alberta dating back to around 79 million years ago, similar in age to the more southern Diabloceratops. It was estimated to be about 6 meters long, though the fossil remains are incomplete, particularly for the facial region. However, it likely had relatively long brow horns and a low, boss-like nasal horn. Additionally, it featured a pair of forward-pointing knobs and 2 large spikes on its frill, although the exact number and arrangement of its other frill ornamentation remain uncertain. Unlike most other centrosaurines, the midline bar of the frill has no bumps or other ornamentation. Xenoceratops probably had a nasal and brow horn configuration comparable to that of other basal centrosaurines. Ceratospoidea was the first and only ceratopsid known from China, and possibly also the only one known from the entirety of Asia. Discovered in the Shandong province, it dates to about 73 million years ago and was one of the larger centrosaurs at an estimated length of at least 7 meters. It had a well-developed nose horn and highly reduced brow horns, and forward-curving spikes around the edge of its frill that gave it a crown-like appearance. Uniquely for a ceratopsid, it also had some protruding bumps just below the spikes, creating a second row of ornamentation. The presence of Ceratospoidea in China shows that at least one lineage of centrosaurs dispersed across to Asia, but they seem to have been quite rare animals on that side of Beringia. While other dinosaur groups such as hadrosaurs and tyrannosaurs seemed to do just fine on both continents, something prevented the ceratopsids from being nearly as prolific as their North American relatives. Wendiceratops was one of the older known centrosaurs, living about 79 million years ago in Alberta, but it had a slightly higher position in the evolutionary tree than more basal forms like Xenoceratops, indicating just how incredibly quickly the early ceratopsids diversified. Partial remains of several individuals have been found, representing both adults and juveniles, with an estimated full size of around 6 meters long. It had forward-curving frill spikes, similar to those of its close relative Ceratopsids, and a large nose horn. The size of its brow horns is unknown, so some reconstructions are based on the fairly well-developed horns of other similarly aged centrosaurs. Lokiceratops was a ceratopsian dinosaur that lived during the late Cretaceous in what is now Montana. Estimated at about 6.7 meters long, it was one of the largest known members of the Centrosaurine branch of the ceratopsians. It had a unique arrangement of ornamentation on its skull, with no nose horn, 2 long brow horns, and a pair of huge asymmetrical curving blade-like spikes on the top of its square frill, some of the largest known frill spikes of any ceratopsian. It lived in a swampy environment near the shore of the western interior seaway, in an area that seems to have had an unusually high diversity of ceratopsians. Along with Lokiceratops there were 3 other ceratopsid dinosaurs. Albertaceratops is unusual in combining long brow horns with an otherwise centrosaurine skull, as Centrosaurines normally possess short brow horns. Over its nose was a bony ridge, and on its frill were two large outwardly projecting hooks. Its size has been estimated at 5.8 meters and 3,500 kilograms. It is known from a single complete skull found in 2001 and skull and postcranial fragments. A phylogenetic analysis carried out by its describer, Michael Ryan, found it to be the most basal Centrosaurine. Additional specimens were reported from a bone bed in the Judith River Formation of Montana. However, further study showed these remains to come from a different Centrosaurine, Megaceratops. Some species of ceratopsians appear to have been gregarious, living in herds. This is suggested by bone bed finds with the remains of many individuals of different ages. Like modern migratory herds, they would have had a significant effect on their environment, as well as serving as a major food source for predators. Megaceratops was a 6-meter-long ceratopsid from the late Cretaceous of Montana. Initially misidentified as Albertaceratops due to its similar brow horns and frill spikes, it was reclassified in 2010 as an early Chasmosaur. However, recent studies suggest it was actually a centrosaur closely related to Albertaceratops. This misidentification also means that many fossils previously attributed to Albertaceratops were actually Megaceratops, found in a mass bone bed likely from a single catastrophic event. Similar mass bone beds have been found for other centrosaurs in the same area and around the same age. Perhaps there were frequent flash floods at the time, or they were attempting to migrate across fast-flowing rivers like some modern animals, but we still don't actually know for certain why they died en masse so frequently. Around 5 meters long, Styracosaurus was one of the most elaborately ornamented horned dinosaurs, with a long nose horn and multiple elongated spikes on its frill. There was actually quite a lot of variation in the frills of Styracosaurus, with varying numbers of long spikes and extra hook-like projections present on some individuals. But one recently discovered specimen nicknamed Hannah is especially surprising. It had a noticeable amount of asymmetry in its skull. The left and right sides show different numbers and arrangements of spikes, so much so that if the two halves had been discovered separately, they might have been identified as belonging to two completely different species. Frill arrangements are often used to define different ceratopsids, so if this level of individual variation and asymmetry existed in other species, too, then we may need to re-evaluate some of them. Styracosaurus' tail was rather short. The skull had a beak and shearing cheek teeth arranged in continuous dental batteries, suggesting that the animal sliced up plants. Like other ceratopsians, this dinosaur may have been a herd animal, traveling in large groups, as suggested by bone beds. Spinops is a close relative of Centrosaurus, and was indeed very similar to it in appearance and general morphology. It is only known from parts of the skull, which include small portions of the frill and the entirety of the nose horn. These skull portions are known from a few individuals, but, given it lived in the same general environment as Styracosaurus and Centrosaurus, it probably wasn't nearly as common, due to the lack of remains known. It is uncertain where exactly it comes from, but it was found in either the Oldman Formation or the Dinosaur Park Formation, and it lived in the Campanian age of the late Cretaceous, approximately 76.5 million years ago, and thus, was also from southern Canada. Ionosaurus is known from hundreds of bones representing over 15 different individuals of varying ages. It had little to no brow horns, and two long spikes at the top of its frill, but also one of the most unusual-looking nose horns of all the ceratopsids, strongly forward and downward curving nasal horn that resembles a bottle opener, though this may only occur in some adults. It had a complex dental battery capable of processing even the toughest plants. It lived in an inland habitat. The juvenile remains show evidence of very rapid growth during their first few years of life, only starting to slow down around age 3 to 5, suggesting that was the point they began to reach reproductive maturity. The largest specimens are estimated to have measured about 4.5 meters long, although they appear to have been subadults who still hadn't quite reached their full size. Ankylosaurus seems to have been a transitional form among the Pachyrhinosaurinae. While slightly more basal members like Ionosaurus had well-developed nose horns, and the later Pachyrhinosaurus had enormous flattened nasal bosses, Ankylosaurus was somewhere in between. Living in Montana, about 74 million years ago, it reached sizes of about 6 meters long. Instead of horns, rough patches of bone on its skull supported bosses over its snout and eyes, which in life would have been covered by thick layers of keratinous skin. Unlike adults, juveniles had small brow horns with bony cores which gradually developed into full bosses as they grew. It's possible that the bosses of mature individuals were used for headbutting or ramming behaviors. Monoclonius was first named by Edward Drinker Cope in 1876. Later, much taxonomic confusion was caused by the discovery of Centrosaurus, a very similar genus of ceratopsian that is known from much better remains. Today, typical monoclonius specimens are usually believed to be juvenile Centrosaurus or subadults, in many cases of other genera such as Centrosaurus. Those specimens that remain under the name monoclonius are mostly too incomplete or immature to be confidently matched with adult specimens from the same time and place. This is especially true of the type species, Monoclonius crassus. Therefore, monoclonius is often considered a nomen dubium now, pending further study. Centrosaurus lends its name to the entire Centrosaur group. It grew up to about 6 meters long and is known from a huge number of fossils from thousands of individuals in gigantic bone beds. These seem to represent enormous herds, making Centrosaurus one of the most common dinosaurs in the region at the time. It had a single large horn on its nose, which started off pointing backwards as a juvenile and changed shape as it grew, gradually hooking forwards. Two especially long spikes at the top of its frill curved strongly downwards, while its brow horns were reduced to small points. Skin impressions are also known from one specimen, preserving a region around the right hip and upper leg, showing a pattern of small polygonal scales interspersed with larger rounded scales. The large frills and nasal horns of the ceratopsians are among the most distinctive facial adornments of all dinosaurs. Their function has been the subject of debate since the first horned dinosaurs were discovered. Common theories concerning the function of ceratopsian frills and horns include defense from predators, combat within the species, and visual display. A specimen from Dinosaur Provincial Park was found to have advanced osteosarcoma in its right fibula. Examination of the cancerous lesions in the bone suggests the cancer had reached an aggressive stage, causing a severe limp that made it more vulnerable to predators. Despite this, it survived longer than expected due to the protection of its herd, but ultimately died in a flash flood that formed the bone bed where it was discovered. Pachyrhinosaurus has become one of the more recognizable ceratopsian names in the last couple of decades, but its remains have actually been known for over 70 years. It was one of the largest of the centrosaurs, with the biggest specimens estimated to have measured up to 8 meters long. Instead of horns, their skulls bore massive, flattened bosses, a large boss over the nose and a smaller one over the eyes. A prominent pair of horns grew from the frill and extended upwards. Pachyrhinosaurus lived in the northernmost regions of North America. This means it inhabited high-latitude environments that likely experienced cold, dark winters, challenging conditions for large herbivores. To survive in these harsh climates, it may have developed specific adaptations, such as a thick, insulating layer of skin or possibly even protofeathers, though there is no direct evidence of this yet. Their nasal boss might have played a role in thermoregulation or signaling within herds. Their fossils have been found in large bone beds, suggesting that they lived in herds. This social structure would have provided protection from predators and possibly facilitated communal foraging or migration in response to seasonal changes in their environment. Some paleontologists speculate that Pachyrhinosaurus might have migrated seasonally to avoid the harshest winter conditions. However, others suggest they were year-round residents, possibly adapting to the long periods of darkness by relying on their sense of smell or by living in forested areas that offered shelter and consistent food sources. The chasmosaurs were the second major branch of the ceratopsids, and ranged throughout most of western North America during the end portion of the Cretaceous. They tended to have larger brow horns than their centrosaur cousins, and more elongated frills that lacked elaborate spikes. Cosmoceratops was discovered in Utah, and had one of the most ornate skulls of any known dinosaur. Living about 76 million years ago, it's known from a partial skeleton and an almost complete skull and is estimated to have measured around 5 meters long. Its frill was relatively short and wide for a chasmosaur, topped with a fringe of 8 long folded-over spikes and a pair of sideways curving hooks. Its brow horns curved sideways, and its nose horn was thin and flattened into a blade-like shape. Overall, it had a total of 15 large horns and spikes, 10 big frill spikes, 2 brow horns, a nose horn, and 2 cheek spikes, along with 16 additional scallops along the sides of its frill. Known from one partial skull and a few pieces of the rest of the skeleton, representing a mature adult about 10 years old, Spiclipius is estimated to have measured between 4.5 and 6 meters in length. Damage to the frill bones on one side of the skull show evidence of an infected injury, possibly inflicted by the horns of another Spiclipius during a fight. The forelimb bones also showed symptoms of arthritis and abscessed bone infection, suggesting this particular fossilized individual had suffered a lot of pain towards the end of its life. The first 2 pairs of Spiclipius frill spikes were fused together, folding forward over the top of the frill, and its brow horns curved out to the sides. Its ornamentation seems to have been transitional between the straighter frill spikes of earlier chasmosaurs and later more elaborately curled forms. Mercuriceratops was a medium-sized ceratopsian, about 4 meters long and weighing around 1 ton. It is distinguished by a unique squamosal bone with a narrowed, rod-shaped rear branch, unlike the typical Chasmosaurine forms. This squamosal had at least 6 to 8 episquamosals on its frill rim. The narrow squamosal suggests that the parietal bones were very wide and had large fenestrae. Mercuriceratops is the oldest known chasmosaurine from Canada and the first pre-Maastrichtian ceratopsid found on both sides of the Canada-United States border. Although its squamosal shape appears transitional between older Centrosaurine and later Chasmosaurine forms, this idea was rejected by its describers due to the lack of similar transitional phases in juvenile Centrosaurines. Despite its name, Pentaceratops only had 3 main facial horns just like most other ceratopsids. The extra 2 horns actually refer to the cheek spikes which protruded out sideways from its face, a feature seen in all ceratopsids to some degree, but especially long and sharply pointed in Pentaceratops. Its frill was one of the largest of all known ceratopsids. During the Cretaceous, flowering plants were geographically limited on the landscape, and so it is likely that this dinosaur fed on the predominant plants of the era, ferns, cycads and conifers. It would have used its sharp ceratopsian beak to bite off the branches which were then shredded, leaves, needles and all, by the tooth batteries, providing a self-sharpening continuous cutting edge in both upper and lower jaws. Ultimately the plant material was digested by the large gut. Like other ceratopsids, Ugueto was a 4-legged plant eater. The elaborate frill and horns suggest a complex social life, perhaps involving displays towards and fights with other members of the species over territory or mating. Multiple individuals are found in a single quarry. It is unclear whether this represents animals brought together by a drought or flood event, or perhaps a herd. It was a relatively large horned dinosaur, reaching 4.3 meters in length and 1.5 tons in body mass. It has a short nose horn, long brow horns, and an elongate frill circled by small hornlets. The back of the frill has a strong notch, giving it a heart shape, with 3 or 4 pairs of spike-like hornlets. Scott Sampson has compared the evolution of ceratopsids to that of some mammal groups. Both were rapid from a geological perspective and precipitated the simultaneous evolution of large body size, derived feeding structures, and varied horn-like organs. According to him, if ceratopsids were to have sexual dimorphism, modern ecological analogues suggest it would be in their mating signals like horns and frills. However, no convincing evidence for sexual dimorphism in body size or mating signals is known in ceratopsids. Alongside fellow Chasmosaurinae terminocavis, also from the Kirtland Formation and described in the same paper, Navahoceratops was found to represent a stratigraphic and morphological intermediate between Pentaceratops and Enchiceratops. Partial remains of 6 different individuals of Utaceratops have been found, allowing for about 95% of the skull and 70% of the rest of the skeleton to be accurately reconstructed, giving a full body length of around 4.5 meters, with the skull alone being over 2 meters long. Its nose horn was positioned quite far back on its snout, and its short blunt brow horns pointed out to the sides. The top of its long frill ended in a U-shaped notch, with the first pair of spikes curving forwards. Despite how proportionally large the skulls of chasmosaurs like Utaceratops were, they weren't nearly as heavy as they might look. Instead of being made of solid bone, there were large openings in the frill, known as fenestrae, that helped to significantly reduce its weight. Chasmosaurus lived on the east coast of Laramidia alongside various species of Centrosaurus, suggesting niche partitioning. Chasmosaurus had a longer snout and jaws, potentially allowing it to be more selective in its plant diet. The function of its frill and horns remains uncertain, with short horns and large fenestrae suggesting limited defensive use. It is hypothesized that the frill might have been used for display, possibly with bright colors for mating or intimidation, though sexual dimorphism is hard to prove. Historically, it was suggested that long brow horns might indicate males and short ones females, but this is no longer supported. A juvenile indicates potential parental care, similar to Triceratops. The juvenile, about 5 feet long and estimated to be 3 years old, had limb proportions like adults, suggesting that both juveniles and adults were not fast movers. The specimen was largely complete except for missing front limbs, which fell into a sinkhole before discovery. Skin impressions and burial evidence suggest the juvenile likely drowned during a river crossing. Chasmosaurus was of a slightly smaller to average size, especially when compared to larger ceratopsians, such as Triceratops, which were about the size of an African bush elephant. Judiceratops is the oldest known member of the Chasmosaurinae, but already shows many of the distinctive features of the group, including the long, concave squamosals and pointed epioccipitals. Along with the presence of specialized centrosaurines such as Albertaceratops at the same time, it suggests rapid evolution of the horned dinosaurs between the Turonian and the Middle Campanian, when Chasmosaurinae and Centrosaurinae show up in the fossil record. This period spans about 15 million years, a relatively short period in terms of dinosaur evolution, suggesting rapid evolution. Although Judiceratops is currently the oldest known Chasmosaurine, it does not seem to be ancestral to later horned dinosaurs. Instead, the specialized features of the frill, the large wing-like hornlets on the margins of the frill, and the reduced ones on the back show that it represents a side branch in Chasmosaurine evolution. Although the horns of Coahuilaceratops are not completely preserved, their absolute size is comparable to the size of the horns of the largest Chasmosaurines. The hyperrobust morphology of the horns is more reminiscent of large specimens of Pentaceratops than of Ugueto. According to estimates given in a press release from the Natural History Museum of Utah, an adult Coahuilaceratops was about 7 meters long, 2 meters tall at the shoulders and hips, with a 1.8 meter skull, and probably weighed about 4 to 5 tons. Its specific traits, such as its relatively short frill and horn configuration, indicate it may have adapted to different ecological niches compared to its contemporaries. This suggests a diversity of ecological roles within ceratopsid dinosaurs. Ceratopsids is relatively rare compared to other ceratopsians and is typically found near marine sediments in the Horseshoe Canyon and Dinosaur Park formations, suggesting it may have lived in estuaries. While flowering plants were becoming more common, ceratopsians like Ceratopsids primarily fed on conifers, cycads and ferns. In 1914, Brown proposed that its unique frill and horns were likely due to sexual selection rather than defensive function. Later, in 1959, Langston suggested a semi-aquatic lifestyle for Ceratopsids, but this idea was largely rejected until Mallon revisited it in 2012, suggesting it could have had semi-aquatic traits similar to modern hippopotamuses. Mallon also noted that it was exceptionally long-lived compared to other ceratopsids, possibly due to reduced competition, less habitat fragmentation, or a more generalist lifestyle. Ceratopsids was a medium-sized horned dinosaur. Compared to other chasmosaurs, it has short but massive brow horns that are relatively short and robust and a long cheek horn on the jugal. The frill was relatively long and had large holes, the parietal fenestrae, separated by an oval-shaped midline bar. It was originally referred to the genus Torosaurus, based in part on the assumption that the fossils dated to the late Maastrichtian. Closer study later revealed that the animal was distinct from Torosaurus. Torosaurus has a flat midline bar of the parietal, while that of Ceratopsids is oval. Furthermore, radiometric dates suggest that the animal is significantly older than Torosaurus, dating to the latest Campanian or early Maastrichtian, rather than the late Maastrichtian. Tatankaceratops is a controversial Chasmosaurine ceratopsian from the late Cretaceous of South Dakota. Known from a single partial skull collected from the Hell Creek Formation and described in 2010, Nick Longrich suggested that it might be a juvenile Triceratops due to its small size and features resembling those of both juvenile and adult Triceratops. The specimen's unusual characteristics, including a long nose horn, led Longrich to propose it could be either a dwarf Triceratops species or an individual with a developmental disorder. Other paleontologists, including Thomas Holtz, suspect Tatankaceratops is simply a juvenile Triceratops. Subsequent studies have generally not accepted Tatankaceratops as a valid genus. The Triceratopsinae branch of the Chasmosaurs first split off somewhere around 75 million years ago, with Titanoceratops being the earliest known member. But they don't seem to have really diversified until several million years later, towards the very end of the Cretaceous 70 to 68 million years ago, around the time the centrosaurs had already mostly disappeared. Regaliceratops is estimated to have measured around 5 meters long. Known from a single near-complete skull discovered in Alberta, the fossil specimen was nicknamed Hellboy for both its stubby brow horns and the immense difficulty of removing it from the surrounding rock. It had highly unusual ornamentation for a chasmosaur, a long nose horn, short brow horns, and large crown-like spikes ringing its relatively short frill, convergently resembling the sort of arrangement seen in many centrosaurs. Titanoceratops was a large ceratopsid, estimated to be about 7 to 8 meters long. It had a robust build and large frill, making it one of the more imposing ceratopsids. The frill was particularly distinctive, featuring a large, well-developed structure with prominent fenestrae. It had long brow horns and a moderately developed nasal horn, which suggests a unique adaptation compared to other ceratopsids. The genus is significant for understanding the transition and diversity within ceratopsids. It provides evidence of evolutionary trends in the Chasmosaurinae, showing how horn and frill morphology evolved over time. A rhinoceratops lived in a wet coastland with warm summers but cool winters. It was likely preyed upon by Albertosaurus. During the Cretaceous, flowering plants were geographically limited on the landscape, and so it is likely that this dinosaur fed on the predominant plants of the era, ferns, cycads and conifers. It would have used its sharp ceratopsian beak to bite off the leaves or needles. Its habitat was densely forested. Since this dinosaur is known only from its skull, scientists have few data about its overall anatomy. The skull, as restored, features a broad, square, neck frill with two oval-shaped openings. The frill is deeply veined on both the top and the underside by arterial grooves. The sides of the frill are adorned by about 9 osteoderms. The rear edge of the frill is lightly scalloped. Ojoceratops is very similar to its close relative Triceratops, though it is from an earlier time period and has a more squared-off frill. Nick Longrich, in 2011, noted that the squared-off frill is also found in some true Triceratops specimens and that Ojoceratops is probably a junior synonym of Triceratops, while Holtz noted that it is probably ancestral to Triceratops and possibly synonymous with the contemporary Eotriceratops. However, Jasinski argued that the genus is valid on the basis of other diagnostic features not recognized by Longrich, including the parietal bar not seen in any Triceratops specimens, the wide-arched squamosal, enlarged base. Maiorino also considered Ojoceratops as a valid taxon in their phylogenetic analysis. Cladistic analyses revealed that Regaliceratops is in a polytomy with Ojoceratops and Eotriceratops. The holotype skull of Eotriceratops is estimated to have originally been around 3 meters long, with the entire dinosaur reaching about 8.5 to 9 meters in length and weighing around 11 tons. It displays unique cranial features distinguishing it from other Chasmosaurine ceratopsians, such as a wide premaxilla process and elongated, flattened episquamosals. The snout of Eotriceratops was relatively flat and elongated, with a distinctive oval fenestra interpremaxillaris and less excavated nasal processes compared to Triceratops. The nasal horn was low, slightly recurved, and had a narrow rear edge. Its forward-curving brow horns were estimated to be 80 centimeters long, with a narrow, vertically directed base. Additionally, the skull exhibits bite marks interpreted as scavenging traces, and the parietal bones, which form the neck shield, are poorly preserved. Bearing a large bony frill, 3 horns on the skull, and a large, 4-legged body, exhibiting convergent evolution with bovines and rhinoceroses, Triceratops is one of the most recognizable of all dinosaurs and the best-known ceratopsian. It was also one of the largest, measuring around 8 to 9 meters long and weighing up to 6 to 10 tons. It shared the landscape with and was most likely preyed upon by Tyrannosaurus, though it is less certain that 2 adults would battle in the fanciful manner often depicted in museum displays and popular media. The functions of the frills and 3 distinctive facial horns on its head have inspired countless debates. Traditionally, these have been viewed as defensive weapons against predators. More recent interpretations find it probable that these features were primarily used in species identification, courtship, and dominance display, much like the antlers and horns of modern ungulates. Although Triceratops is often depicted as a herding animal, evidence of this behavior is limited, with only one known bone bed in Montana containing 3 juveniles. In 2012, 3 Triceratops of different sizes were found in Wyoming, suggesting they may have traveled as a family unit, but it's unclear if they were a mated pair with offspring or 2 females with a juvenile. Their remains showed signs of predation by Tyrannosaurus, including broken and punctured bones. Triceratops fossils are common, with skulls far more frequently found than postcranial bones, indicating a high preservation potential. Their teeth, organized into batteries, suggest they consumed large amounts of fibrous plant material. The function of their horns and frill is debated, with theories ranging from combat to courtship display, with the latter gaining more acceptance. Recent studies suggest Triceratops may have had an ectothermic metabolism, similar to modern reptiles. Additionally, Triceratops' growth patterns indicate significant changes in horn and frill development as they aged, with some debate over whether Torosaurus represents a mature form of Triceratops.